Question 10. Find the basis for row space of the following matrix. So first, remember the theorem. Always remember these important theorems. If you have a matrix, and if it's row equivalent to another matrix, well, this matrix is much more simpler than the original matrix, hopefully. Count the number of non-zero rows. It's going to be the rank, and also those non-zero vectors form a basis. Let's take a look at this guy. So first of all, get rid of this 2 by dividing the first row by 2 or multiplying by a half. This guy becomes 1, negative 3 halves and a half. This guy must be 0, so multiply this by negative 5 and add it to the second row. This guy becomes your new second row. Very good. So you have negative 5, then you have 15 over 2 and negative 5 over 2 added to 5, 10 and 6. This is 0. And here you have 35 over 2. And here you have 12 minus 5, 7 divided by 2. So this guy becomes 0, 35 over 2, 7 over 2. And now you're going to multiply the first row by negative 8 and add it to the third row. And this guy becomes your new third row. So here you have negative 8, and here you have 12 and negative 4 added to 8, negative 7 and 5, which is 0, 5, and 1. So we're good here. Now multiply the second row by 2 over 35. So 2 over 35 multiplied by R2 becomes your new R2. So this is just 1, and 7 over 2 times 2 over 35, which is 7 over 35. Well, now you need to multiply the second row by 3 halves and add it to the first row. 3 halves R2 plus R1 becomes your new R1. So here you have 0, and you have 3 halves, and you have 3 halves times 7 over 35. Add it to 1, negative 3 over 2, and a half. So here you have 1, 0, and get. Okay, we can factor out a half if it makes it easier for us. 21 over 35 plus 1 or a half, 35, and here you have 56. We can simplify this as 28 over 35. So this guy becomes 0 and 28 over 35. Very good. Now let us move on and simplify this guy. So we're going to multiply the second row by negative 5, add it to the third row, and this guy becomes our new third row. So 0, negative 5, and here you have negative 5 times 7 over 35, which is basically negative 1. And then you have 0, 5, and 1. So this guy is 0, 0, 0. Luckily for us, we ended up with a row which is basically 0. So what does it tell us? It tells us that let's just simplify this as well. We have basically 2 non-zero rows. So this guy becomes 1, 0, 4 over 5, 0, 1, and 1/5, 0, 0, 0. So our row equivalent matrix has 2 non-zero rows. It means that our original matrix, which is A, has a basis including 1, 0, 4/5, and the other guy is 0, 1, and 1/5. So basically, you can write any vector as a linear combination of these two vectors. So the rank of the row space of matrix A is 2, because we have 2 elements in the basis. Again, if I ask you to find the basis for column space, just a note, column space, you just need to write down the transpose of the matrix and reduce that guy. So here you get 2, -3, 1, 5, 10, and 6, 8, -7, and 5, and do the process all over.